Good day. So this time we will do some clustering exercise using K-means, no, and we will use the iris data set as our data set for this exercise, and uh, for our for our environment we are going to use the Python. We are going to use the Jupyter Notebook. Okay, so let's start. Okay, so uh, clustering analysis, or why are we doing some clustering analysis? So clustering or cluster analysis is a type of unsupervised learning technique used to find commonalities between data elements that are otherwise unlabeled or uncategorized. So the goal of this clustering is to find distinct groups or clusters so within a data set. So we are grouping or clustering uh, some some the sets of data, and when we use machine language algorithm, in this time we are going to use K-means. So this tool creates groups where items in a similar group will have similar characteristics to each other. So in this time we are going to play around with uh, iris data set. So we are going to group or to cluster iris data set uh, through its sepal length and sepal width. So let's start. And also, no, I would like to emphasize that for this exercise, we are going to use the elbow method. Now, elbow method is the most popular, in determining the optimal value of K. So let's start. Okay, so I have a new notebook. So for the sake of time, so I do not need to code each line. So I have just actually I have a running code already. So no, for the imports, okay, and then after importing some libraries, so we have to load the iris data set, or the iris CSV. Okay, and then after that, so oops, wait. Okay, so again, so uh, let's load the iris data set or our CSV file for iris. Okay, so as we can see, we have loaded, no, and let's check uh, how many rows and how many columns we have. So we just have to load the data frame, yeah, and then we see if 150 rows with 5 columns for iris dataset. And then okay, so after that, so we need to let me use the load function for iris, and then data frame. So for the data frame, let's set the data frame, and let's just put some names or the target names for our data frame. By the way, the iris has 3 species. Name of the species are Setosa, versicolor, and virginica. Okay, so now we have set columns and the target names, and then uh, let us check again the data frame, and then after that we have to load again data. Let's check again the data. Okay, so in array, so we have presented the array of the data sets. Okay, and then let's use some scatter plot. Okay, let's visualize this time our data set. You are using scatter plot. Okay, and then after that, we have to plot again using pair plot. Okay, pair plot. So when we use pair plot, actually we are observing, we have observations for like joint distribution of the in the triangles, and then we have also marginal distribution in the slant line. We can see that okay, so we can see that actually, Setosa, the species Setosa is extremely short petal width, while the Virginica have high sepal length. So, yeah, using pair plot, can visualize their clusters per species. Okay, and then we have to now let's use elbow method. So this time the value of our k-means is 5, and let's do some prediction. Let's perform predictions. Okay, so and then now let's find all the rows of x that have a y value of 0. So given that y is equal to 0 and are in the first column of x. So example, sepal length. Now for sepal length, let's check its let's find the rows now of x that have y value. So similarly, x is equal to the parameters of x is y is equal to 1, and I mean y is equal to 0 and uh, 1. So let us find all the rows of x that have y value. Let's check. So we have to use the colors, a color red, blue, green, cyan, magenta for each cluster. Okay. So now we have clustered them. Now we have visualized the clustering uh, of the species by sepal length and sepal width. Now let's check. Okay, so using elbow method, we have to output a graph. The shape of elbow is approximately formed at K3. Okay, so whenever there is error, so let's just check now whenever there's and then we have to put the results into a line graph, allowing us to observe the elbow. So the graph will expectedly form or in the form of an elbow. Oops, what's this? Okay, and then uh so as we can see in our graph, the optimal value of k is between 2 and 3. So therefore we tweak we tweak our k-means. We this time we have to put the k-means equal to 3 with random state 21. Okay, so, and then let's identify the center points of the data. Center point of the data using the k-means tree. Okay. And then let's apply k-means to the data set. And let's create k-means classifier. So now our cluster has been trimmed down to 3. Okay. And then after that, we have to plot the identified clusters plot and compare the answers. Oops. Oops. Okay. So this is comparison between actual and predicted. And then Let's plot the identified clusters and compare with the answers again. So comparing the actual petal length and petal width with prediction. Okay. So actually the output is very good. And now yeah, so let's do this one. We have to visualize the original data versus the clustered results. And then yeah, that's it. So based on the original data, so we can see actually right now, so yeah, our clustered results is just closely identical to the original data. So our K-means clustering is found to be so efficient for iris dataset. Okay, with the K-means 3. So that's it. See you in the next session.